Hey, what's up, guys? John here. And this time, let's take a look at this LeetCode problem here, which is number 983, minimum cost for tickets. In a country popular for train travel, you have planned some train traveling 1 year in advance. Okay, blah, blah, blah. Probably we can skip all this kind of description here. So the key point is here, you have like a array of days, okay? And each day is an integer from 1 to 365. And then you have another like array which has a cost, okay? A cost that only has three elements. The first one is the 1 day pass, second one is a 7 day pass, and the third one is a 30-day pass. Basically a daily pass, a weekly pass, and a monthly pass. And so if you purchase like the pass on the ice day, okay, on the ice day, you can travel from I to I plus 7 days, okay, just like what the examples, what the description is telling us, okay, and then it asks you to find the minimum number, basically the minimum cost you need so that you can travel all the days that's inside the days array here, okay. Mm, So, I mean, this is like, I think it's kind of obvious. This is like a DP problem, you know. So for the DP problem, uh, as usual, let's try to find the state transition function here. Basically, we have a DPI, right? So the DPI means uh, at the ice day, okay? It means that we have traveled like ice day, okay? And then the minimum cost, okay? Minimum cost. Mm, so I think it's kind of easy, right? I think you can somehow, I think it's not that hard to find this one, right? So basically basically from we have a DPIs, right? So how many ways we can, right, to get to the current DPI, right? Basically we have like three ways, right? We can either coming from the daily pass or the weekly pass or the monthly pass, which means uh we can purchase a ticket at I minus 1 day, right? So which means we have a cost 0, okay, plus dp I minus 1. So this one means that basically we purchase like a daily pass on I minus 1 day, and so that then we get to the current day, okay? Or dp I minus 7. Or we could have like purchased a weekly pass on the I minus 7 day, right? Then we can also get to the DPI here. Or like cost, right? Cost 2 plus dp I minus 30. Okay. Basically that's the dp the state transition function. Or we can by or we could have about like a monthly pass on the I minus 30 days, right? With the cost number, the third cost, okay? But only if you're only using this one function, we will not get the correct answer. Why is that? Because so this thing is right, it's assuming that we travel on each day, right? We're assuming that on each day we need to travel, but But the problem is telling us, it's asking us only travel the minimum cost to only travel on these specific days. Okay, so that's the trick here. So you know this DPI equals to these things only when this DPI is is in the uh, in the days. Okay, so what if this days I is not in the days? So then the DPI equals to what? Simply equals to the DP I minus 1. Okay, so this is something that you need to be careful here when I is not in days. So for example, right? I mean, for example, if we are calculating DP like DP3, okay. So DP3 is not one of the days where we need to travel. So what does it mean? It means that it is equal to DP2 basically, because we don't need to purchase any tickets on this day, right? So that we can simply use the previously state where DP2 is also equals to DP1, right? So because when we calculate DP2, since DP2 is not in the it's not in the days either, so we just go back to the DP1. Okay, so it means that let's say we so for DP1, right? So DP1 we purchase like a daily pass, right? Then the DP1 has a cost. Okay, so the DP1 has a cost. I think in this case it's 2, right? Yeah, I think it's 2. So the DP1, the cost, the value of DP1 is 2, and so the DP2, okay, so for to travel to DP2, the days is equals to 2, right? Now, uh, the basically our definition here on I stay most cost, okay, but on day 2 we don't need to travel, okay, we can just stay at home, right? That's that's why the cost at DP2 is still $2 because we don't have to travel on day 2. Same thing for day 3 here, right? So basically for we travel on the first day, and on day 2 and day 3 here we simply stay at home. So which makes our cost stay at 2. Okay. Only when we see when we at day 4 here we know, okay, so now we have to travel. Then it's time for us to use this formula. Okay. Okay. Cool. So that's that. And some of you may have a question. So for the current DPI here, right? Why I have to buy the tickets on the starting on the I minus one, and let's for example let's using the weekly pass as an example here. I mean, why I have to buy the tickets at exact I minus 7 day? Why can't I buy the tickets, let's say at I minus 3? Okay, right? I mean, if we buy the tickets at I minus 3 days, yeah, it can also cover the DPI stay, right? It can also cover the I stay. True, but but since we're calculating the minimum value here, right? Mm, you know, there's one thing you guys need to understand. Basically, the DPI minus 4 is greater or equal than the DP than the DPI minus 7. Okay, I think this is something this is not that hard to understand, right? Let's say the I minus 4 is greater than the I minus 7, right? And then the DPI minus 4, basically it means that to travel until the I minus the cost to travel until the I minus 4 day has to be greater than the cost we travel to the I minus 7 days, right? It's pretty obvious, right? So that, if we use the I minus 4, I mean, we could have simply loop through everything, right? We could loop through everything from I minus 7 to I here, to I minus 1. Okay, so here, we could just loop through everything from I minus 7 to I minus 1 with the DP here. But since we already know, we already have this uh, equation here, we know that the I minus 7 must have the smallest number among all the values in the range of I minus 7 to I minus 1, so that we don't have to consider I minus 4 or I minus 3 or I minus 2, since we're calculating the minimum value, right? That's why we only need to use the dp I minus 7. Basically, you know, I think there is a little bit of a greedy concept here. Basically, we're trying to get the minimum cost, the bare minimum tickets that can cover to the current I stay for both, for all the daily pass, the weekly pass, and the monthly pass. Okay. Mm, yeah. So okay. So if you can come up with this one and two and this two formula, then you pretty much have done 90% of the thinking process of this problem. So now, okay, so let's try to code these things up here. And I'm going to use like both the top down and bottom up solution to solve this problem. Uh, let's try, let's start with the top down, yeah, which is the recursive plus memorization. Okay. Uh, DP, I'll just define the I here. So the I means the I stay, okay? And then uh, memorization return dp1. Okay, basically we start as the first day. Okay, yeah, we start at the first day. And if I in memorization, okay, we return memorization I. Okay, the answer equals to system dot maximum size. Okay, and yeah, I think everything I'm writing here is just like a template. Okay, so here, so what's our ending point, right? We need to have like the base case, which is the ending point. Basically, if the I is greater than what? Then the last day minus 1, okay? And then we simply return 0. Because, why I'm using the last one? Because we only care about we if we can travel to the end of all the days, right? Even though there are like 365 days, but we don't care about all those other days. All we care is what's the minimum cost. So we can travel until this day. That's why I'm using this like the last day in the days here. Okay. Uh, oh yeah, and to check if the current number is in the days array here, it's always a good uh, habit to convert the days list into a days set, okay, so that we can greatly improve the performance here. Yeah, so now basically if the I is not in days set, okay, then we can simply do what? We simply do answer equals to the dp uh, I plus 1. Yeah, so I mean the top down and bottom up is a little bit different because the top down we're thinking as like from the current space from the current day. If we purchase a ticket, if we purchase a ticket at the current day, then we can travel that many days, right? And then we just pass the rest of the informations to the next recursive call. So same thing for this one. Basically, if the current day is not, if the current day I don't need to travel, then I don't need to worry about the current day. All I can just pass the question to the I plus 1 day. Okay. Okay. And else, right? So if the current day, if the current days is in the days here, then we know, okay, we got three options here, right? We have a cost 0, right? Cost 0. If we purchase a ticket, if we purchase the daily tickets, then we can travel to the I plus 1 day. Okay, minimum. Okay, or we can purchase a weekly tickets and then travel to I plus 7 day, right? Or we can purchase like the monthly pass and we can travel to uh, I plus 30. Okay. Mm, yeah, I think that's pretty much it is, right? So I think we're missing a parenthesis here. And then the rest is just the regular DFS, not the top-down DP template. And let's try to run it. Okay, pass, submit. Cool. So this one, see it pass. Basically, the top-down. So for the top-down DP solutions, the idea is we're always looking forward. Okay, and for the bottom up, we're always looking we always look backwards. Okay, so that's why I mean for this one, like we look forward. It means that if we purchase a ticket at the ice day, we can travel to this day. Okay, and by the time we passed the the last day, I mean we don't use a equal here because we want to make sure and the last day can also be processed. I mean if we use this one, let's say if we use like a equal here, it let's say it what if the i's happen to be the last day, right? And then we simply return 0, which is not correct because on the last day, what if we want to travel on the last day? Probably we might also need to buy 1 day tickets. Okay, that's why instead of greater or equal than the last day, we do a greater here. Okay, so pretty straightforward, right? I think that the only tricky part is like this one, basically for both the top down or bottom up. So if I is not in the if I is not in the date set, I mean it means that we don't have to travel. It means that we can simply move the state forward by 1. Otherwise, we just try all the 3 possible uh, passes here, and then we collect the different costs, and then we pass this to the future days. Okay, so that's the top down. Okay, let's do a bottom up. So like I said, the bottom up is always looking backwards. Okay, the DP. Actually, the diagram I was drawing on the screen was actually for the bottom up. Was not yeah, that was for the bottom because I was using the I minus 3, I minus 1, or I minus 7. Okay, and so to do a bottom up, we have to initialize initialize the DP array beforehand. Okay. So and the size, right? So how about the size? I mean, we could like initialize like 365 slots, but like I said, we don't need that many, right? All we need is like is up until this days. Okay. So that's why I'm gonna use the days minus one plus one. Okay, so I do a plus one because if let's say if the last one is 20, right? If I just do a 20 here, right? I mean the days here will be from 0 to 9 to 19, right? If I do a range here to 20, but I want to use the date itself. I don't want to use the zero base. That's why I do a I do a 20 plus one, which is 21, so that we have a 0 to 20 in our DP here. It's easier for me to align with the days here. Okay, so now for right for DP for I in range, that that's the day we would be looping through, right? So from the first day to the last day is this, right? Okay, remember, so the end the end point is like is exclusive, right? That's why we do a I plus one to make sure we can loop through to this last day. Okay, so same thing here. I think we also need this thing here, this one. Answer equals to no, we don't need this. Okay, so if the I is in range, sorry, is not in. Okay, so let's do a not in here, just same as the other one, the above solution here. So then the DPI equals to what? Equals to DPI minus one. Okay, so like I said, for the bottom-up DP solutions, we always look back. Basically, for the current DP solutions, what are the ways we can get to the current DP state? So the first one is if the current day is not in our like itinerary, so it's not in our travel plan, then we don't have to travel. So we can just simply inherit the cost from the DPI minus one day. Okay. And since we have a DPI minus one and we are starting from one here, we have to initialize DP0. Okay, otherwise everything will be will be an infinite number here. So DP0 means zero, right? It means that at the 0 days, the cost will be zero. It means that we don't need to buy a ticket. At day zero means that we don't travel. Okay. Else is similar as this one basically. Else similar like DP I equals to the minimum of cost 0 plus dp I minus 1, okay, and then cost 1 plus dp I minus 7, okay, or the cost 2 plus dp I minus 30, okay, and in the end we simply return the dp, the last one, okay, and the last one which is the last day, right? But here I think there's a little trick here because since we're starting from one here, the I minus 7 and the I minus 30 could have gone to the negative values, right? So that I mean this one is fine because it's I minus 1, it's always like greater or equal than 0. But for this one, we don't want it to go beyond 0, right? So that we can just always do a max 0 and that, right? We simply do a max 0 with the I minus 7 and the same thing for this one. Basically, we bound it to the 0. Okay. Mm, cool. Yeah, I think that should do it. Let's try to run it. Cool. And submit. Yeah. As you guys can see, the bottom up is faster than the top down because the top down it has like this recursive call so that the program or the compiler or the runtime has to spend additional time to remember each state of the recursive call so that it can be returned to its caller. But for the bottom up, right, all we have is just a for loop. Okay, and yeah, and cool. So the time and space complexity, right, is pretty straightforward, I guess. The time is it's O of n, right? So it's like n is actually the n is the length of the last day, right? And the space is also the length of the last day. Okay. Yeah, I think that's pretty much for this problem. Basically, I described both the top down and bottom up, you know. Again, so for the top down, we always look forward, right? That's why we do a I plus something. And for the bottom up, we always look backwards. Okay. Mm, cool. And other than that, it's just this one. I think this is something. This if statement is something you guys need to remember. Basically, if there's something that we don't have to do at DPI, we can always do a DPI minus one. You know, I think it's similar like the string DP problem. If the Yeah, basically, and because yeah, probably I shouldn't have gone that far. And for this problem, I mean, if we don't have to travel at the current day, basically we don't have to spend any money, and we still want to calculate this like this ice day, right? Because otherwise, otherwise if we don't calculate the days that we don't have to travel, when we when we at the days we need to travel, right? And when we go back to the I minus one or I minus seven, the values we're getting is not basically we couldn't correctly inherit the previously cost. Okay, that's why this step is critical. So we have to calculate the I state regardless of it's in our travel plan or not. And the way we're calculating is we just inherit from the I minus one. Cool. I think that's pretty much it is I want to talk about for this problem. Thank you so much, guys, for watching the videos and stay tuned. See you guys soon. Bye bye.